Hello and welcome back to our second video. Today we'll be looking at exercise 4E. And exercise 4E is looking at parallel and perpendicular lines. Now what does parallel mean and what does perpendicular mean? So let's take a look at this picture I have for you here. Not sure why it's zooming out. Okay. Let's take a look at this picture here. Focus on the orange and blue line. Line A and line B. We can see that these two lines are traveling side by side. And if we continue to extend this line in both ways, we can start to see, or we can state, that these two lines will travel side by side indefinitely. It will travel side by side forever, and they will never meet each other. That is the definition of a parallel line. Lines that are traveling side by side and will never meet. So what is the characteristic of a parallel line in terms of the gradient? And I'm going to write down the definition here for you. Parallel lines travel side by side. They will never meet. Okay? And I'll put a very important statement here. The gradient of parallel lines are the same. Okay? I'll put that up here as our definition. This is the very important part. The gradient of parallel lines are the same. Okay, for example, I'm going to write two linear equations for you. Y equals to 4x plus 7. And that are a second equation. Y equals to 4x take away 12. Now what is the gradient of the first line? The gradient of the first line is 4. Okay? What about the gradient of the second line? The gradient of the second line is also 4. Since the gradient are the same, these two lines are parallel. Okay? Let's take a look at a few more examples. What if I gave you the line y take away 6x equals to 14 and y equals to 11 plus 6x. Are these two lines parallel? Well, that's hard to tell until we do some rearrangement. Let's rearrange this first one here. So this one becomes y equals to 14 plus 6x. Okay? Now let's compare the gradient of each line. Alright, the gradient here is 6 because the 6 is in front of the x. Positive 6 to be exact. And the gradient for this line here is also 6. Since gradients are the same, these two lines are parallel. Okay? Parallel lines. Alright, let's take a look at a few more examples. What if I have, let's go back to green, 7x plus y equals to, let's do 14, and I have 2y equals to 10x take away 5. Okay? Let's rearrange the top one to make y the subject. Y equals to 14 take away 7x And let's transpose the second one. Because I got a 2 times here, I need to divide both sides by 2. Okay? So divide this side by 2, divide this side by 2, okay? So these two cancel out to leave it y, and then I got 10x over 2, take away 5 over 2. I just split the fraction up. Y equals to 5x, because 10x divided by 2 is 5x, take away 5 over 2. I'll just leave this as a fraction. It doesn't really matter for our case. Now let's take a look at the gradient. The gradient of the first line is negative 7x. Okay? And the gradient of the second line is positive 5x. Is negative 7 and 5 the same?
No!
That's right. They are not the same. This line and this line are not parallel, okay? So the easiest way to determine if a line or a pair of lines or more are parallel is to rearrange it to make y the subject and then look at the gradient for each one. Example. Let me paste the example here. Okay, the question is asking, write a rule for a line that is parallel to the graph of y equals 4x plus 3 and has a y-intercept of negative 5. Parallel means the gradient has to be the same, and the gradient for this graph here is 4. Okay? So we know that our new line needs to also have a gradient of 4. So let's write the general formula. Y equals mx plus c. Y equals 2, m is 4, x plus c. And then they tell us the y-intercept is negative 5. So we chuck it in. Y equals to 4x take away 5. And that's how we would do that question. Very, very easy. Alright, let's take a look at another question. Let's go back to the book. Okay, let's try this one here. Alright. Write a rule for a line that is parallel to the graph of y equals to 2x minus 5 and passes through the point 3, 1. So, first of all, let's take a look at this graph here, okay? What is the gradient? The gradient is 2. Okay? Now let's fill in the rest of the question. We know the graph of a straight line is always y equals to mx plus c. Therefore, we have y equals to 2x plus c, because 2 is the gradient. Now we need to find c. In order to find c, I need to sub in a point. I'll sub in this point into my x and y to find c. Okay? So I've got 3 is my x and 1 is my y. So I can sub it in. 1 for the y equals to 2 times x, and I saw that x is 3 plus c. 1 equals to 6 plus c. Therefore, c equals to negative 5. Now that I found c, I can put it back and write my equation. So my equation is y equals to 2x, and I got my minus 5 here, okay? And that is how you do that question. Looked at parallel lines, and that was quite easy. Now we can look at something called perpendicular lines. Perpendicular lines, okay? Now what are perpendicular lines? Perpendicular lines are when you have two straight lines and they cross each other at 90 degrees. For example, let's take a look at this picture again. Okay, I'll clear this out. Okay, now let's take a look at this one here. We can see we've got line A, which is the blue line, and we've got the pink line, line C, and they meet each other at this point here, which I put in green. And we can see roughly that they cross each other at 90 degrees, okay? And since line A and line B are parallel, that means that if line C crosses line A at 90 degrees, then line B and C will also cross at 90 degrees, okay? So perpendicular means to meet at 90 degrees. Let's write the definition here. Let's get my typing pad out. Perpendicular lines meet at 90 degrees. And then I'll make a statement about the gradient. The gradient of perpendicular line is the negative reciprocal. Okay? What does a negative reciprocal mean? Let's take a look at a few examples. So if I have, let's say, a line. Let's say I have a line and the gradient of the line is 4. Alright? Now I know 4 can also be written as 4 over 1. They mean the same thing, don't they? They are the same. Now first of all, we're going to find the reciprocal. The perpendicular line will have a gradient of, the reciprocal means you take a fraction, you turn upside down. So 4 over 1 becomes 1 over 4. Okay? And we need to find the negative. So that means that the whole fraction becomes a negative. Okay? So 4 over 1 becomes 1 over 4, negative. Let's try 2 more examples. If I have a line that has the gradient of m equals to 17, then the perpendicular would be equal to 1 over 17 negative. Okay? If I have a line that has a gradient of, let's say, 2 over 5, then the perpendicular gradient would equal to 5 over 2, because I flipped the fraction upside down, negative. What if the original line was the negative gradient? What happens then? Let's say I had a line which had a gradient of negative 6, then the perpendicular gradient would be, okay, 6 becomes 1 over 6, and because there's a negative here, we wouldn't have a negative in the perpendicular line. It becomes a positive, okay? Always the opposite sign. Let's try one lucky last one. If I had a line and the gradient was equal to negative 3 over 4, then the perpendicular line would have a gradient of 4 over 3. Because it's a negative here, there'll be a positive there. Alright? Quite easy, isn't it? Now let's take a look at some examples. Let's see a few from the book. Alright. Here we are. This one's a good one. I'll scroll down. Why does it make it so small? It makes absolutely no sense at all. Alright, write the rule for a line that is perpendicular to the graph of y equals to 3x minus 4 and has a y-intercept of 2. So the original graph has a gradient of 3. So that means the perpendicular graph has a gradient of m equals to 1 over 3, which is the reciprocal, negative. And I know that my straight line always has the form of y equals mx plus c. Y equals to m, I found here to be negative 1 over 3, x plus c. Now I need to find c. And I know c is the y-intercept. And they tell us the y-intercept in the question. So it becomes 2. So our equation becomes y equals to negative 1 over 3 x plus 2. Quite a simple question, isn't it? Now if I graph this on the calculator, I will see that we'll have the two lines meeting at 90 degrees. So let's try that actually. Here, I'm going to put in the original equation that they gave us in the question. So that was y equals to 3x minus 4. And then I'm going to graph my second equation, which we found to be y equals to negative 1 over 3 x plus 2. And we can see here quite clearly that these two lines, oh my goodness, these two lines cross at 90 degrees. Okay? That's a good proof. Okay, let's try another question. Let's see this one here. This is a good question too. Write a rule. Write the rule for a line that is perpendicular to the graph of y equals to negative 4x minus 7 and passes through the point negative 8 and 3. Okay, so we see the gradient here is negative 4. So the perpendicular gradient has to be equal to, so 4 becomes 1 over 4, and because there's a negative here, there won't be a negative in our perpendicular gradient. So the gradient is just 1 over 4. So let's finish the question. Y equals to mx plus c, y equals to 1 over 4 x plus c, and to find c, I've got this point here given to us. So I'll put the 3 into the y equals to 1 over 4, and then I'll put the negative 8 into the x plus c. Then I'll just go ahead and solve for c. 3 equals to negative 8 divided by 4 is negative 2 plus c. Therefore c equals to 5. Now to complete my question, I need to write the equation now properly. Y equals to 1 over 4 x, and the c is 5, so that's plus 5. Quite an easy question. Now let's end this video with one final question, and that question can be one of the horrible big word problems. That is quite interesting. Alright. Okay, the 3 parts to this question, let's work through them one at a time. Alright, a line segment joins negative 6 and 7 and 0 and negative 11. Write a rule for the linear graph that is parallel to this line segment and passes through the origin. So first of all, we need to find the gradient of this line segment. So the line that joins this to this. So let's look at question A. The gradient is equal to y2 take away y1. So y2, negative 11, take away y1, which is 7, over x2, it is 0, take away x1, which is negative 6. Okay? Put that in bracket. M equals to negative 11, take away 7 is negative 18, divided by 0, take away negative 6, positive 6. Therefore, M is equal to negative 3. So we know that a straight line has to be in the form of y equals to mx plus c. Y equals to m is negative 3, x plus c. And we know it passes through the origin, and the origin is the point 0, 0. So we know x is 0 and y is 0. So we can put that into the equation. Y is 0 equals to negative 3, x is 0, plus c, therefore c is 0. So we can put this together to be y equals to negative 3x plus 0. So the equation is y equals to negative 3x. Now, once again, like I said last time, some people may not notice, but you can just read the y-intercept directly from this passage here. Because if the line passes through the origin, then the y-intercept has to be 0. Okay? But some people might not recognize that. So to substitute the point, you'll get the same answer. You might be wasting an extra 20 seconds. It doesn't really matter. Let's take a look at question B. I'll do question B here. We want to find a perpendicular line to this segment, and it passes through the point negative 6 and 7. So if the original gradient is negative 3, then the perpendicular gradient would be, so we've got negative 3, that becomes 1 over 3, and because it's negative here, our perpendicular gradient becomes positive. So B, 1 over 3. The straight line is y equals to mx plus c, y equals to 1 over 3, x plus c, and to find my c value, I'll need to use the point given. It passes through the point negative 6 and 7. So 7 goes into the y, and negative 6 goes into the x plus c. 7 equals to negative 6 divided by 3 is negative 2 plus c. Therefore, c equals to 9. And our equation becomes y equals to 1 over 3 x, and we found c to be 9. Alright? Now I'm going to do question C here, so we can still see the question. We want to find a line that's perpendicular and passes through its midpoint. Now we haven't learned midpoint yet, but I'm going to teach you how to do midpoint right now. Midpoint of 2 points, that means when you have a line and you join the 2 points together, what is the point that is exactly in the middle of that line? So the midpoint formula is very easy. Midpoint, you know, a point has the x and y component. So first of all, the midpoint is equal to x1 plus x2. The x1 and x2 are exactly the same as how we use for the gradient formula. So we'll take x1 plus x2 divided by 2, and the y part, so there's a comma right there, would be y1 plus y2 divided by 2. Okay? So let's find the midpoint for our question here. So we'll look here, let's call this x1, y1, and this one can be x2, y2. Okay? So the midpoint, I'll call it MP, equals to, okay, x1 is negative 6 plus x2 is 0 divided by 2. And y1 is 7 plus y2, which is negative 11 divided by 2. Now let's simplify that. Negative 6 plus 0 is negative 6, divided by 2 is negative 3. 7, take away 11 is negative 4, divided by 2 is negative 2. Now we want to find the line that is perpendicular to our original line and passes through this point. So we know that from part B, the perpendicular gradient was 1 over 3. So that is y equals to 1 over 3 x plus c. And to find c, we'll just sub in this point here, which is the midpoint. Negative 2 for the y. Actually, I change colour. Negative 2 equals to 1 over 3, and x is negative 3 plus c. So it becomes negative 2 equals negative 1 plus c. Therefore, c equals to negative 1. So our equation overall becomes y equals to 1 over 3 x minus 1. Now I hope you found these questions useful. I will put the questions that you need to do up onto Teams, as well as some worksheets for you to complement this topic with. If you have any questions, let me know via email or on Teams, and I'll wish you all the best with this topic.